Hello Legacy Sabers. So today we're going to look at our next part of factoring, which is factoring using grouping. What you're going to want to have on you, your notes, a calculator, perhaps to do maybe some division, and then a pen or a pencil as well. So how and when are you going to use this method of factoring? Well, very first thing you're always going to want to do is check for a greatest common factor. GCFs, okay? You're going to want to check to make sure that it is not present in the problem before you do factoring by grouping. Otherwise, you're going to not have a lot of trouble doing it. When you're going to use this, you're going to use this when you have 4 terms. So this polynomial has to have 4 specific terms in it to be able to use factor by grouping, which we're going to probably call the box, okay? So, whoa, that should be a pencil right here, not a random ants problem. Okay, so factoring by grouping is basically inverse multiplication, if you want to think of that. Basically, it's inverse multiplying 2 binomials together. So what we're going to do, guys, is basically we're going to use the box method inversely, like you guys have been using for multiplication. So we have 4 pieces, right? So each piece is going to go inside of each of these, if you want to call them a window. Okay? Now, what's going to happen is on the outside here, we're going to find the greatest common factor of that particular row. So if I want to find the greatest common factor of these 2 particular terms, I need to look and see what are they. So it looks like I have a 3 and a -12, so a 3 is the biggest that can come out of both of those, right? And then 2 n's, so n squared, so 3n squared would be what I would be able to take out. Okay? Now, ultimately, guys, remember it was this times this gave us that, right? So what times 3n squared would give me 3n cubed? N, right? Just an n. N times 3n squared should give me 3n cubed. Double check as well. These 2, is their greatest common factor just n? So 3 and 2, they have no factors in common. So it looks like I'm just going to be pulling out a 1 or nothing at all. And then the n's, there's only one n between the 2 of them that they both can give. Thus, my greatest common factor for this column would be 1n. Now, let's look at this bottom row here. 2n and -8. Well, it looks like they both share a 2, but not both of them share an n, so it's just going to be 2. Double check. Is 2 times 1n 2n? It is. Now, final one. Let's figure out what this is. So something times 2 has to give me a -8. What times 2 gives me -8? -4, right? So I should get a -4 right there. Let's make sure that we got the same answer for here. -4 times 3n squared, that's -12n squared. So that is my final answers around the edges. So what I can do is rewrite my answer. I have 1n minus 4 and 3n squared plus 2. That is my final answer. Now notice, guys, I could remultiply this back out and I should get this exact same problem that you started with. Okay? Let's try this one again. So make sure first, is there any greatest common factor that can be yanked out? Doesn't look like it, right? 2, but 2 doesn't go into 35, so we can just leave it as is. So let's go ahead and draw in our box. Boop. Like this. Got 8t to the third. I'm going to make sure my t, there we go. 14t to the second, 20t, and 35. So let's try to find a greatest common factor of this row right here. So what can come out of 8 and 14? 4 can come out of 8, but 4 can't come out of 14. I'm thinking it's just 2, right? 2 would be my greatest common factor. of my numbers, and then it looks like t squared is the most t's that I can take out of both of those terms, right? So then let's start asking yourself some multiplication questions. What times 2t squared is going to give me 8t to the third? 4t, right? Because 4 times 2 would give me 8, and t times t squared would give me t to the third. Now let's figure out what the greatest common factor is of this. Not a t in there. So this one doesn't have a t as well. 5 it looks like, right? And let's double check. Does 5 times 4t, that is 20t. So that is correct. And then 5 times something needs to give me 35. A 7, right? 7 times 5 is 35. So it looks like my outsides are 4t plus 7 times 2t squared plus 5. And notice, guys, if I would multiply this completely back out, plus 20t, 14t squared plus 35. Notice, guys, it is the exact same problem. So what you are doing, you're basically finding greatest common factors and you're undoing FOIL method. Ultimately, that's what you're doing. By factoring, you're undoing the FOIL method, or when we were using the box. You're undoing that ability. So basically, you're dividing away things that are present in the first two equations and the second two equations. There is a different way, not using the box, and I will show you in class while we're working on that. But let's try 2 more problems before we're done. So, you know what? Here, look at these. 4q to the 4th minus 8q to the 3rd plus 12q to the 2nd minus 24q. You know, I think a 2 can come out of all of those. Right? Let's take a 2 out. Let's see. So I'm going to have 2q to the 4th minus 4q to the 3rd plus 6q to the 2nd minus 12q. You know what? I could take a 2 again and a q as well. Do you notice how they all have q's? So if I take another 2, I'm actually going to be having a 4q for my greatest common factor outside, right? So if I took out a 2 again, so I'll just be q3 minus 2q2 plus 3q minus 6, right? Now let's go ahead and use our box method, or factor by grouping, on this second part right there, okay? Because that other part is just our greatest common factor. We do not need to put that in the box. So I got 3q and negative 6. So these guys have in common a q squared. Then q squared times something needs to give me q cubed, which would be just a q, right? Q times q squared is q3. These guys have in common a 3. And then 3 times something needs to give me negative 6. Or negative 6 divided by 3, I could look at it that way. That would be negative 2, right? Then negative 2 times q squared, that is negative 2q squared. Got it. So now, be careful, guys, though. When you write your answer first, so I'm going to write my outsides. But notice, guys, this would not get to exactly what we started with. We do need to make sure this 4q happens to pop up in front of it. Otherwise, you aren't actually factoring all the way. You're not showing that we pulled out that greatest common factor first. So basically what we're doing is we're using 2 methods of factoring together to accomplish the task of factoring this actual polynomial right there. Last one. Let's first check what can we pull out. Is there anything? So I got 6, a 9, a 12, and an 18. I want to say 6, but 6 doesn't go in a 9. What about 3? So let's pull out a 3. Can I pull out any H's? Yeah, I can. They all have an H, so let's pull out an H. So it looks like we'll have 2h cubed plus 3h squared plus 12 divided by 3, 4h plus 6, right? Let's go ahead and box that piece. That's the polynomial yet. 2h cubed, 3h squared, 4h, and 6. Looks like I got just an h squared present, right? Because 2 and 3 don't share a number at all. Something times h squared needs to give me 2h cubed. Well, it's got to be a 2, right? Because there's technically a 1 there. So 2 times 1 would give me 2. And then I need one more h, it looks like. These two guys have a 2 in common, right? 4 and 6. And then if I double check, 2h times 2 is 4h. And then 2 times something needs to give me 6, which is just 3. So my answer is 2h to the plus 3 times 1h squared plus 2. Oh, thanks for reminding me. We also got to put that 3h in front. Can't forget about a greatest common factor. And that's the end of this video. See you later, Sabers.